life we will come across many objects which are in motion, right? That is, there are two types of objects. That means we can differentiate between the objects as the stationary objects and non-stationary objects. That means the moving objects. We have seen different types of objects, that is stationary objects and moving objects. The objects which cannot be moved according with the time. That means, for example, take this stick or take this marker, right? When I place it on this table, it is just remaining on that place, right? Therefore, we can say these type of objects are stationary objects. Now, let us see some more examples such as birds, right? These birds will fly. They are moving objects, right? They move from one place to another. And at the same time, fishes will be swimming in the water and they will be moving from one place to another. And at the same time, the blood in our nervous system, in the veins and in arteries of our body, this blood will be flowing, right? That means it is moving or it is changing its position from one part to other part. Therefore, we can say that blood also flows. That means it is coming under the category of moving objects, right? Now let us see galaxies. Galaxies consist of many stars, the Milky Way, everything, and all those are rotating objects because they move around the sun. For example, let us take sun as center, and the planets like Earth, Mars, Jupiter, every planet will be rotating around the sun, and the sun is also a revolutionary object. That means it rotates itself around its own axis, right? These are the best examples in the nature, and these are the moving objects what we see. And let us see the molecules and atoms by which the matter around us is formed. Those molecules and atoms are also a moving objects, right? That's why the atom is existable, right? And also let us see the air. Suppose how can we say that air is a moving object? We cannot predicate because we cannot exactly see that air is moving with our naked eye. But we can predicate by using the help of the leaves falling from or the papers pushing away by the wind or breeze, and by those things we can say that air is moving object, right? That air is flowing, wind, breeze is coming by the experience or by the feeling or by the objects related to that are moving due to the presence of air. That means we can say that motion are complex. That is, motions are complex. Motions are complex means we cannot exactly say that air is moving by seeing air exactly, and we are predicating by the help of other objects, right? That way it is very complex in nature. Let us see one more example. That is, suppose you are traveling in a bus, right? For you, the trees behind you will be going back away from you when you are moving in the bus, right? When you are moving in the bus, the trees or objects, anything behind or will be moving away from you. You feel as if they are moving away or they are moving back of you, and you are moving in a frontward direction. But the person who is on the beside of the road or roadside, the person, he feels that as if you were moving, and the trees which are present in between him, besides him, will be as stationary for him. That means the moving objects will be differ from one person to another. That means according to the position of the person, the moving objects will be different. See, for the person who is moving in the bus, he feels that the trees are moving for him. But for the person who is on the roadside, he feels that the bus and the passengers in the bus will be moving according to him, right? Therefore, we can say that motions are complex and they will be different from one person to another according to the positions and according to their motions, right? Therefore, there are different types of motions. That is, a motion can be easily said that it can be having a shape of straight line, that is, it is flowing in a straightward direction or forward direction, and it can be as circular. That means, for example, let us take sun and planets. The planets revolve around the sun in circular motion, right? And for example, radiate and vibrate, rotate operations. That means, for example, take the pendulum of a clock, right? The pendulum will be rotating or moving to and fro. That is vibrating or radiating to and fro motion. And examples like such as many more examples we can see that like suppose let us take washing machine. That's the washing machine will be rotating round like in round shape, that is in circular motion. That means some objects will be moving in straightward, some will be in rotating, and some will be in circular, or some will be in vibrating. Therefore, the motion can be in any way. That means it is differed according to the object and according to the direction they are moving, right? And let us see the motion of the objects which are passing in a straight line manner. With the help of some graphs and some views, we can understand the motion of objects which are moving in straight line. See how to describe a motion. That is, describing a motion means, for example, take one object, right? When it is you are giving the reference point for that object. That means, for example, the Charminar is there, right? It is located near to the some bangle shop, whatever famous shop you will be seeing. That means, one more example like I want to give is, for example, let us take Birla Mandir. It is opposite to the Secretariat, right? That means the Secretariat is the reference point for the Birla Mandir. Let us see the description of emotion, or how to describe emotion. And I have taken a best example, that is Birla Mandir and Secretariat will be the reference point for the Birla Mandir, right? That means basic example why I want to give that a school is there and it is 2 kilometers north of railway station. For example, take us Nampalli railway station, right? Our school like Little Flower School is 2 kilometers north from railway station. Then this railway station is known as the reference point for this school, right? Therefore, in order to describe any object's motion or any place of an object, we will be giving the reference point for that. That is, the reference point itself is known as the origin of that particular object, right? Then we can say that we have already said we will be discussing the objects which are having the motion in a straight line. Therefore, motion along a straight line we will be discussing. This is the simplest part of different objects, and let us assume or let us give a good example, that is, here the origin O is the starting point, and this is the straight line path of an object, and the distance covered by the object at particular points is noted down, that is at B point, C point and A point, and the object is travelling from origin O, this is the reference point, and it travelled up to A, and it is coming back in the same direction up to B. That means it is travelling a distance of OA plus AB. That is, the B is the end point for that, and the OA plus AB will be equals to the total distance covered by the object. This is the starting point and this is the end point. That means it is going in a straight line up to here and it is coming back to its final position, right? Therefore, the distance covered in the forward path is 40 kilometers and in the backward direction is 5 plus 5 plus 5, that is 15 kilometers, right? 40 plus 15 kilometers will be giving us 55 kilometers is the total distance covered by the object. Suppose this is the first or initial position of an object and A is the final position of an object, and the shortest distance between O and A, that is initial and final positions of an object, is 40 kilometers, right? Thus we can state that the shortest distance as displacement, and the displacement is given as only the values, right? Numerical values 40, 30, 50. Therefore we can say that the numerical values, that means the distance have only magnitude and there is no direction in order to mention the distance covered by an object. Okay, I hope you are getting very clearly. That is, the distance covered will have only a physical quantity, that is numerical value, that is the magnitude of the displacement, and it doesn't have, or we don't want to show the direction of how much it is covered, right? We are just showing the distance between the initial and final positions. Therefore, it is not a vector quantity. We are not showing any direction. Therefore, it is a scalar quantity. Displacement is a scalar quantity because any quantity which is showing only the magnitude and no direction, then that quantity is said to be a scalar quantity. Okay. Now we can also say, is the displacement will be equal to the length of the path? That means, for example, it is the initial position and this is the final position. This is the length, right? This is the length, right? How much length it is covered? 0 to 40 kilometers, right? 40 kilometers. Again, we are subtracting this. That means this is the final, initial and final position, right? This is the distance between these two, right? That means 1, 2, 3, 4, 5. That means 25 kilometers is the shortest distance. That is the displacement of the two objects. But the distance covered by the object is, we have said 55 kilometers, right? That means it went like this and it came back like this. And this total distance covered is 55 kilometers, and the shortest distance between the initial and final positions, it is 25 kilometers. Therefore, we can say that the distance measured or the magnitude of displacement, or the distance between the shortest or the initial and the final positions is not equal to the path of the length. The path of the length may be different, but the distance between the or the magnitude of displacement between two initial and final points is different. Now I can say, if this is my starting point, I went to A and again I came back to O. That means this is my starting point and at the same time this is my ending point, right? Therefore the displacement is 0 because I have went 40 kilometers and I came 40 kilometers. That is, here itself I am there. That means the displacement is 0. But the distance what I covered is 40 plus 40. That is 80 kilometers. Therefore, I can say that the magnitude of displacement is not equal to the path of the length. This is the statement of what I am saying. Hope you understood this. And let us move for the next point, that is uniform and non-uniform motions. Now let us see excuse me, the uniform and non-uniform motions. For example, let us take an object is moving 5 meters in 1 second and one more 5 meters in another second and another 5 meters in third second. Like that it is moving 5 meters per 1 second. Therefore, we can say that the objects which are covering a same distance in same intervals of time, then those objects are said to be uniform motion. They are in uniform motion. Suppose I give a good example that let us take one bus. It is covering around 20 kilometers and it is reaching the first stop, and again it is taking 20 kilometers to reach the second stop. That means it is taking an equal intervals of time in order to reach equal stages, that is first stage, equal distance stages, right? Therefore, they are said to be uniform motion. I said previously, a moving object means the object's position will be changed according to the time. Then it is said to be in motion. So we can give a good example like, see, we will be getting summer season, rainy season, winter season. All those seasons are why? Because that is none other than the reason, that is the earth is moving. We cannot see that as if we feel that it is stationary. But the earth is moving around itself and it is also moving around the sun. Therefore, while sometimes it will be nearer to the sun, that will be a summer season, and when it is farther to the sun, it will be for us winter season. Like that, according to the seasons and according to the temperature between those, according to the revolution between the earth and the distance between the sun and earth, we will be getting the seasons and changes, the climatic changes, right? At the same time, the uniform motion objects means the objects which cover at the same distance at same equal intervals of time are said to be uniform objects, and they are known as in uniform motion, right? And let us see the non-uniform objects or non-uniform motion objects. That is, the distance covered is unequal. Suppose in first 5 seconds it will cover about 50 meters. In next 5 seconds it will be covering about 100 meters. That means it is not maintaining its certainty. It is varying from one time to another time. The distance covered by the object varies from time to time. That is said to be unequal distance in equal intervals of time. Then it is said to be non-uniform motion. For example, let us take a good example in Hyderabad is very traffic. like we are starting from Medipatnam to Amirpet, and it is very fully crowdy and very traffic. And the path is very full of traffic, and we will be going in 1 hour. We will be taking at least 1 hour to reach from Medipatnam to Amirpet in a traffic situation, right? If at all in the early morning times, that is at 7 o'clock like that, there will be no traffic, right? We will be taking just only 15 minutes to reach from Medipatnam to Amirpet. That means we are taking same distance, we are traveling the same distance